Good morning, everyone. So, myself, B.V. Vamsi Krishna, Assistant Professor, Department of Physics, AKNU, Rajahmundry. So, in previous class, I have discussed the tunnel diode. So, tunnel diode operates in forward bias condition, and when voltage increases, the above the uh, the what built-in potential, the current electric current will decreases. So but today I'm going to discuss about photodiode. This photodiode is operates in the reverse biased condition. So yeah, what does it do is it consumes the light energy and convert it into the electrical energy. So photodiode is a simply a p-n junction semiconductor device that consumes electrical light energy to generate electric current. It also sometimes referred as a photodetector, photosensor. So, this photodiode is operated in the reverse bias conditions. Reverse bias condition means negative terminal of the battery is connected to the p-type semiconductor, and positive terminal of the battery is connected to the n-type semiconductor. As I said, in p-type the majority carriers are holes, minority carriers are electrons, whereas in n-type semiconductor majority carriers are electrons and minor carriers are holes. So so when we join this n-type and p-type semiconductor, so there will be a flow of electrons when external voltage is not connected. So when external voltage is not connected, when we join n-type and p-type semiconductor, so there will be a flow of electrons from the n-type to the p-type semiconductor. So after certain time there will be a formation of a depletion region. Okay. So when we connected the negative terminal, okay, so when we connected this negative terminal to the p-type semiconductor, so there will be a repulsion between this negative charge of this battery to the electrons in the p-type semiconductor, so that this electron try to move towards the n-type semiconductor, but there will be repulsion between this electron this electron and electrons in the depletion region. So there will be small current will generate in the reverse bias condition also. So after certain time there will be a no electron will pass through the p type to the n type semiconductor. Okay. So that so as I discussed, that the reverse bias means the p-type side of the photodiode is connected to the negative terminal of the battery, and then n-type n side is connected to the positive terminal of the battery. Okay. How it works: a normal p-n junction diode allows a small amount of current when under the reverse bias condition. I already said that, because why it is produce a small amount of electric current, because there will be a electric repulsion between the negative charge of this battery to the electrons, magnetic charge carriers in the p type. There will be repulsion between the negative charge of the battery and magnetic charge carriers. These electrons will push, means will move in towards the p-type semiconductor. So there will be a repulsion between this charge carrier and negative charge, means the electrons, and the electrons in the depletion region. Okay. So to increase the electric current under reverse bias condition, we need to generate more magnetic carriers. For reverse bias condition low, if we want to increase the electric current, we should generate more more free electrons. Okay, if we generate more free electrons, then will be more current will generate in the reverse bias condition. So external reverse voltage is applied to the PN junction diode will supply energy to the magnetic carriers but not increase the population of magnetic carriers. So whatever I explained in few minutes back, okay, it is written in the words. Okay. However, a small number of magnetic charge carriers are generated due to the external reverse bias voltage. As a result, no electric flow due to these charge carriers. So why it is not produce the charge carriers? Because of so this whatever these electrons, the electrons in the p type cannot it will move towards the n type, but it cannot cross the depletion region. This while depletion region is there, right? So it cannot, these electrons cannot cross over the this depletion region. So there will be a flow, there is no current produced in the PN junction diode in the reverse biased condition. However, for example, the magnetic carriers generated in the p-type semiconductor experience the repulsion forces from the external voltage and try to move towards the n side. I already said to you. Okay. However, before crossing the junction, the free electrons recombines with the holes within the same material as the result of no current flow, no electric current flows. To overcome this problem, we need to apply external energy to the depletion region to generate more charge carriers. So what happening in the PN junction diode when reverse bias condition, reverse bias voltage is applied? So what happening is when negative terminal of the battery is connected to the p type, the electrons in the p type, okay, get it experiences the repulsion forces. This repulsion then the electrons will due to the repulsion forces, the electrons in the p type will move towards the n side, but there will be repulsion again. There will be repulsion between these electrons in the p type and electrons in the depletion region. So these electrons in the depletion region will move towards the n type. Okay. So there will be no flow of electric current. So to overcome this problem, we need to apply external energy directly to the depletion region. So to generate more charge carriers. So when we apply the light energy, to the depletion region, this what happens is these electrons in the depletion region will move towards the p-type semiconductor. The holes will move towards the n-type semiconductor. So then there will be a flow of electrons in the circuit. So there will be generation of electric current. A special type of diode called photodiode is designed to generate more number of charge carriers in the depletion region. In the photodiode, we use the light or photons as an external energy to generate charge carriers in the depletion region. Okay. What I am trying to say is when light is subjected to the means are applied to the depletion region of the photodiode, then the electrons in that depletion region will tend to move towards the p-type region. The holes are tend to move towards the n-type region. Then there will be a flow of electrons in the circuit. Okay, let's see the applications. It is used in the compact displayer, smoke detectors, space applications. Photodiodes are used in the medical applications such as computed tomography instrument to analyze the samples and pulse oximeter. Photodiodes are used for optical communications. Thank you. This is all about the photodiode. So in next class I will explain about solar cell and LED and Schottky diode. Thank you.